Question number 11 says that we need to write a polynomial in general or standard form. That simply means do any math that's there. General or standard form is ax to whatever power plus bx to the 1 less plus cx to the 2 less, etc. So for this, that just means that I'm going to distribute the 4x squared across the entire quantity. So that gives me an answer. Y equals 8x to the 4th plus 12x cubed minus 28x squared. So I just distributed everything. It's general form. I've got it in order decreasing degree. Okay? And there's no more math that I can do. Question number 12. This is asking us to use our graphing calculator to find where this function has any local maximum and minimum values. So what I've done here, I graphed it on my calculator. Now I used a standard window initially, which is just zoom 6. After that, I changed the window a little bit because I wanted to see where it had, like, think of it as a roller coaster. I wanted to see where the bottom of a hill was and where the top of a hill was. Okay? So, I zoomed in a little bit. I went from -2 to +2 on the x-axis. And I'm just going to pinpoint where this is. They're just asking me where it is. And that's an x value of -1 and a y value of 9. And this one over here has approximately an x value of 1/2 and a y value of 2. Now, it's a multiple choice test. So what you're going to have is you're going to have options. So it's like an educated guess. You're going to look at the graph. You're going to say, oh, this is about here. Okay, and then you choose that option. Okay, question number 13. Create a polynomial that has these roots. Okay, so what we do, we just write out, they've got 3 roots. So what I'm going to do is I'm just going to write factors that have these x values as intercepts. So that means x minus 0, x plus 2, and x minus 5. I chose the opposite of each one of those. 0 is its own opposite. It's kind of special that way. So I chose x plus 2 because -2 plus 2 would be equal to 0. Roots and x-intercepts are the same thing. They're also called zeros of the function. And I chose x minus 5 because 5 minus 5 would be equal to 0. Question number 14 says, be able to look at a function and find the x value which maximizes it. Now, very simply, what you're going to do in a problem like this is you're going to have a picture of a function, and you just need to be able to look at that function and figure out what x value gives it its highest y value. Now that's bent back a little bit. Not such a good picture, but you get the idea. What's the highest point on this function? Right here. What's the x value? -2. That's all. Tell me what x value gives you the highest y value. Okay, so question number 15. Parent function is y equals 1 over x. So we need to do some things to this function. We're going to follow alphabetical order. Reflect, stretch, translate. So we're going to put in our reflection first. That gives me, just put in a negative. It will flip that function appropriately. Next thing we want to do is we want to put in a vertical stretch factor. Vertical stretch means multiply the entire function. So I'm going to multiply the entire function by 2. And now I've got y equals -2 over x. Next, I'm going to reflect this or translate this to the left 7 units. So I'm going to do that. Left is in a negative direction. I'm going to do that by adding 7. And lastly, I'm going to go up 4 units, so I'm going to add 4 to the entire function. So extend that a little bit, and that should accomplish my goal. You can always check it on a calculator. You will have a calculator to make sure that you have accomplished